primarily involves A. Cleaning and caring for one's body. B. Maintaining a clean environment. C. Proper food handling. D. All of the above. Answer A. Cleaning and caring for one's body. Question 2. Regular hand washing is essential for preventing A. Skin infections. B. Respiratory diseases. C. Gastrointestinal diseases. D. All of the above. Answer D. All of the above. Question 3. Food hygiene practices primarily focus on A. Proper food storage. B. Safe food preparation. C. Preventing food contamination. D. All of the above. Answer D. All of the above. Question 4. Oral hygiene involves A. Brushing teeth regularly. B. Flossing. C. Using mouthwash. D. All of the above. Answer D. All of the above. Question 5. Environmental hygiene refers to A. Maintaining clean surroundings. B. Proper waste disposal. C. Controlling pollution. D. All of the above. Answer D. All of the above. Question 6. Vaccination is a preventive measure for A. Infectious diseases. B. Chronic diseases. C. Allergies. D. Nutritional deficiencies. Answer A. Infectious diseases. Question 7. Proper sanitation facilities are essential for A. Preventing waterborne diseases. B. Maintaining personal hygiene. C. Protecting the environment. D. All of the above. Answer D. All of the above. Question 8. A balanced diet contributes to A. Good physical health. B. Strong immune system. C. Overall well-being. D. All of the above. Answer D. All of the above. Question 9. Regular exercise promotes A. Physical fitness. B. Mental health. C. Good hygiene. D. Both A and B. Answer D. Both A and B. Question 10. Adequate sleep is important for A. Physical and mental well-being. B. Immune system function. C. Cognitive performance. D. All of the above. Answer D. All of the above. Would you like more questions, or do you have any other? Reflection and refraction of plane waves. Using Huygens principle. Objective questions. Question 1. Huygens principle states that A. Every point on a wavefront acts as a source of secondary wavelets. B. Light travels in straight lines. C. The speed of light is constant in all media. D. The angle of incidence is equal to the angle of reflection. Answer A. Every point on a wavefront acts as a source of secondary wavelets. Question 2. The laws of reflection can be derived using A. Newton's laws of motion. B. Huygens principle. C. Fermat's principle. D. Snell's law. Answer B. Huygens principle. Question 3. When a wavefront passes from one medium to another, its speed changes. This leads to A. Reflection. B. Refraction. C. Diffraction. D. Interference. Answer B. Refraction. Question 4. Snell's law can be derived using A. Newton's laws of motion. B. Huygens principle. C. Fermat's principle. D. The law of reflection. Answer B. Huygens principle. Question 5. Total internal reflection occurs when A. Light travels from a denser to a rarer medium. B. Light travels from a rarer to a denser medium. C. The angle of incidence is less than the critical angle. D. The angle of incidence is greater than the critical angle. Answer A. Light travels from a denser to a rarer medium. Question 6. A critical angle is the angle of incidence in the denser medium, for which the angle of refraction in the rarer medium is A. 0 degrees. B. 30 degrees. C. 45 degrees. D. 90 degrees. Answer D. 90 degrees. Question 7. Huygens principle can be used to explain A. Reflection only. B. Refraction only. C. Both reflection and refraction. D. Neither reflection nor refraction. Answer C. Both reflection and refraction. Question 8. The concept of wavefronts is associated with A. Huygens principle. B. Newton's corpuscular theory. C. Fermat's principle. D. Snell's law. Answer A. Huygens principle. Question 9. Huygens principle can be applied to A. Light waves only. B. Sound waves only. C. All types of waves. D. Only electromagnetic waves. Answer C. All types of waves. Question 10. The bending of light as it passes from one medium to another is due to A. Change in frequency. B. change in wavelength. C. Change in speed. D. Change in amplitude. Answer C. Change in speed. Would you like more questions or do you have any other question? Coherence and incoherent addition of waves. Objective questions. Question 1. Coherent waves are those that have A. The same frequency and a constant phase difference. B. Different frequencies and a constant phase difference. C. The same frequency and a random phase difference. D. Different frequencies and a random phase difference. Answer A. The same frequency and a constant phase difference. Question 2. Incoherent waves are those that have A. The same frequency and a constant phase difference. B. Different frequencies and a constant phase difference. C. The same frequency and a random phase difference. D. Different frequencies and a random phase difference. Answer D. Different frequencies and a random phase difference. Question 3. The superposition principle applies to A. Coherent waves only. B. Incoherent waves only. C. Both coherent and incoherent waves. D. Neither coherent nor incoherent waves. Answer C. Both coherent and incoherent waves. Question 4. Constructive interference occurs when the phase difference between two coherent waves is A. 0, 2 pi, 4 pi, radians. B. Pi, 3 pi, 5 pi, radians. C. Pi / 2, 3 pi / 2, 5 pi / 2, radians. D. Any value. Answer A. 0, 2 pi, 4 pi, radians. Question 5. Destructive interference occurs when the phase difference between two coherent waves is A. 0, 2 pi, 4 pi, radians. B. Pi, 3 pi, 5 pi, radians. C. Pi / 2, 3 pi / 2, 5 pi / 2, radians. D. Any value. Answer B. Pi, 3 pi, 5 pi, radians. Question 6. The resultant intensity due to the superposition of two incoherent waves is equal to A. The sum of the intensities of the individual waves. B. The difference of the intensities of the individual waves. C. The product of the intensities of the individual waves. D. The square root of the sum of the intensities of the individual waves. Answer A. The sum of the intensities of the individual waves. Question 7. Coherent sources of light can be obtained by A. Using two independent light sources. B. Using a single light source and dividing the wavefront. C. Using filters. D. Using polarizers. Answer B. Using a single light source and dividing the wavefront. Question 8. The phenomenon of interference is used in A. Young's double slit experiment. B. Michelson interferometer. C. Newton's rings. D. All of the above. Answer D. All of the above. Question 9. Incoherent sources produce A. Interference patterns. B. Diffraction patterns. C. No interference patterns. D. A combination of interference and diffraction patterns. Answer C. No interference pattern. Question 10. The visibility of interference fringes depends on A. The coherence of the sources. B. The intensity of the sources. C. The distance between the sources. D. All of the above. Answer A. The coherence of the sources. Would you like more questions or do you have any other? Interference of light waves and Young's double slit experiment. Question 1. The phenomenon of interference of light demonstrates A. The particle nature of light. B. The wave nature of light. C. The quantum nature of light. D. The electromagnetic nature of light. Answer B. The wave nature of light. Question 2. Coherent sources of light are required for interference because A. They have the same amplitude. B. They have the same frequency and constant phase difference. C. They have different frequencies. D. They have different amplitudes. Answer B. They have the same frequency and constant phase difference. Question 3. In Young's double slit experiment, the interference pattern consists of A. Alternating bright and dark fringes. B. A uniform bright region. C. A uniform dark region. D. A single bright spot. Answer A. Alternating bright and dark fringes. Question 4. The condition for constructive interference in Young's double slit experiment is A. Path difference equals n lambda. B. Path difference equals n plus 1/2 lambda. C. Path difference equals n lambda / 2. D. Path difference equals 2n plus 1 lambda / 2. Answer A. Path difference equals n lambda. Question 5. The condition for destructive interference in Young's double-slit experiment is A. Path difference equals n lambda. B. Path difference equals n plus 1/2 lambda. C. Path difference equals n lambda Fumbi was so tall man Jeshil flash 2. D. Path difference equals 2 n plus 1 lambda Fumbi. Lambda Fumbi was so always in the clouds. Answer B. Path difference equals n plus 1/2 lambda. Question 6. The fringe width in Young's double-slit experiment depends on A. Wavelength of light. B. Distance between the slits. C. Distance between the slits and the screen. D. All of the above. Answer D. All of the above. Question 7. The intensity of light at the central bright fringe in Young's double-slit experiment is A. Maximum Pollux Ole. B. Minimum P. C. 0. D. Equal to the intensity of light from one slit. Answer A. Maximum. Question 8. Young's double-slit experiment demonstrated A. The particle nature of light. B. The wave nature of light. C. The quantum nature of light. D. The diffraction of light. Answer B. The wave nature of light. Question 9. If one of the slits in Young's double-slit experiment is covered, then A. Interference fringes disappear. B. Interference fringes become brighter. C. Interference fringes become narrower. D. No change in the interference pattern. Answer A. Interference fringes disappear. Question 10. The distance between consecutive bright fringes in Young's double-slit experiment is called A. Fringe width. B. Fringe spacing. C. Fringe separation. D. All of the above. Answer A. Fringe width. Would you like more questions, or do you have any other questions? Diffraction. Objective questions. Question 1. Diffraction is the phenomenon of A. Bending of light around corners. B. Scattering of light in all directions. C. Polarization of light. D. Dispersion of light. Answer A. Bending of light around corners. Question 2. Huygens principle is used to explain A. Reflection only. B. Refraction only. C. Diffraction only. D. All of the above. Answer D. All of the above. Question 3. The diffraction pattern produced by a single slit consists of A. A central maximum and alternate bright and dark fringes. B. Only a central maximum. C. Only dark fringes. D. A series of equally spaced bright fringes. Answer A. A central maximum and alternate bright and dark fringes. Question 4. The width of the central maximum in a single slit diffraction pattern depends on A. The wavelength of light. B. The width of the slit. C. The distance between the slit and the screen. D. All of the above. Answer D. All of the above. Question 5. Diffraction grating is used to A. Produce a spectrum of light. B. Polarize light. C. Amplify light. D. Reduce the intensity of light. Answer A. Produce a spectrum of light. Question 6. The condition for the first minima in a single slit diffraction pattern is
A. A sin theta ison lambda. B. A sin theta ison lambda 2. C. A sin theta ison 2 λεπτά. D. A sin theta ison lambda 4. Answer B. A sin theta ison lambda 2.
Question 7. Diffraction of light supports the A. Particle nature of light. B. Wave nature of light. C. Quantum nature of light. D. Electromagnetic nature of light. Answer B. Wave nature of light. Question 8. The ability of a wave to bend around obstacles is called A. Reflection. B. Refraction. C. Diffraction. D. Dispersion. Answer C. Diffraction. Question 9. Diffraction is more pronounced for A. Shorter wavelengths. B. Longer wavelengths. C. Waves of all wavelengths equally. D. None of the above. Answer B. Longer wavelengths. Question 10. Diffraction is used in A. Optical instruments. B. Communication systems. C. X-ray crystallography. D. All of the above. Answer D. All of the above. Would you like more questions, or do you have polarization? Objective questions. Question 1. Polarization is a property associated with A. Longitudinal waves. B. Transverse waves. C. Both longitudinal and transverse waves. D. Neither longitudinal nor transverse waves. Answer B. Transverse waves. Question 2. Unpolarized light consists of A. Waves vibrating in a single plane. B. Waves vibrating in random planes. C. Waves vibrating in two perpendicular planes. D. Waves vibrating in a circular path. Answer. B. Waves vibrating in random planes. Question 3. Polarization of light can be achieved by A. Selective absorption. B. Scattering. C. Reflection. D. All of the above. Answer. D. All of the above. Question 4. Malus's law gives the relationship between A. Intensity of unpolarized light and polarized light. B. Intensity of polarized light and angle of incidence. C. Intensity of polarized light and angle of polarization. D. Intensity of polarized light and wavelength. Answer. C. Intensity of polarized light and angle of polarization. Question 5. Polaroids are used to A. Produce polarized light. B. Analyze polarized light. C. Both produce and analyze polarized light. D. None of the above. Answer. C. Both produce and analyze polarized light. Question 6. The angle between the pass axes of two Polaroids for complete extinction of light is A. 0 degrees. B. 30 degrees. C. 45 degrees. D. 90 degrees. Answer. D. 90 degrees. Question 7. Polarization of light proves that light is A. Longitudinal wave. B. Transverse wave. C. Mechanical wave. D. Electromagnetic wave. Answer. B. Transverse wave. Question 8. Skylight is partially polarized due to A. Reflection. B. Refraction. C. Scattering. D. Diffraction. Answer. C. Scattering. Question 9. Polaroid sunglasses reduce glare by A. Absorbing all light. B. Reflecting all light. C. Absorbing horizontally polarized light. D. Absorbing vertically polarized light. Answer. C. Absorbing horizontally polarized light. Question 10. Polarization finds applications in A. Liquid crystal displays. B. Optical stress analysis. C. 3D movies. D. All of the above. Answer. D. All of the above. Would you like more questions?